Alright, so again, if you have a question or clarification, so you may interrupt me anytime and then ask right away. Alright, so we've stopped here in capacitors. And one more thing that I need to clarify this one is for electrolytic capacitors. So as you can see, it is polarized, and then it is mostly has a unit of microfarad. Okay, and then for ceramic disc, this one is sometimes or mostly are in picofarad or nanofarad. Okay, for the bigger one, which is the electrolytic, it is in micro. Right. So next one is diodes. So what are diodes? So diodes are components which are polarized. So the same with the electrolytic capacitor, it also has a polarity wherein you have to follow that one, or else it will not accept or it will not allow electricity. Okay, so they only allow electrical current to pass through them in one direction. Okay, so the other one, if you have a polarity of, say, clockwise, it will not work. You should only have a counterclockwise or vice versa. Okay, so depending on the polarity of that diode. So this is useful in that it can be placed in a circuit to prevent electricity from flowing in the wrong direction. Okay, so actually the main purpose of this one is uh, to have an accurate connection. Say you've accidentally put the power the other way around instead of the ground, so it will not short circuit. Okay, in other words, it will not allow or it will not allow the current to pass through. So another thing to keep in mind is that it requires energy to pass through a diode. Okay, and this results in a drop of voltage. So mostly it requires uh, a voltage of 0.7. That is for silicon, and then 0.3 for germanium. So those are the most common semiconductors that we use, or this diodes that we use. So to make it simple, diodes it's electricity. Okay, it needs this certain amount of voltage before you can pass through completely. So let's say you have a circuit here, okay, and then you have a diode. So your voltage source should be higher than that diode. So what do I mean by that? So for example, you have a series of diodes, let's say two diodes. So if you're going to sum those two, that's already 14 if it's 0.7 each. So in other words, you should have a 1.4 volts, not 14, sorry. So in other words, you should have 1.5 and above voltage source. Because if you only have, let's say, 1.3 volts, yeah, so it will not be able to pass through on that uh, diode. So think of that as mm, a payment, okay? A payment for you to be able to pass through to that gate. So it is like a gate wherein it requires a money or a ticket, okay? Wherein that ticket is amount of 0.7 volts. So the ring found on one end of the diode indicates the side of the diode which connects to ground. So this is the cathode, and then for the positive one or the other side is for the power, which is the anode. So anode positive, cathode is the negative one. So this is the uh, positive side, and then the other one is the oops is the negative side. Okay, so the triangle one is the anode, and then this one is the cathode. Oops, what happened? Why is your color? There you go. All right, so next one is transistors. So what are transistors? So a transistor takes in a small electrical current at its base pin and amplifies it such that a much larger current can pass between its collector and emitter pins. So the amount of current that passes between these two pins is proportional to the voltage being applied at the base pin. Okay, so we have two types of transistors, the NPN and then the PNP. or the negative, positive, negative, and then the positive, negative, positive. Okay, so these transistors have opposite polarity. Okay, so as you can see, it's very opposing. Then another one is negative, positive, negative, and then another one is positive, negative, positive. Okay, opposite polarity between collector and emitter. So for a very comprehensive intro to transistors, check out this page. Yeah, so you can just click the control and then left click this one, then it will lead you to that page. That is if you want to know more about the further details or a more detailed information when it comes to transistors. So let's talk about NPN. So NPN transistors allow electricity to pass from the collector pin to the emitter pin. Okay, so they are represented in a schematic with a line for a base, and then a diagonal connecting to the base, and a diagonal arrow pointing away from the base. So NPN, there you go. So the one that has an arrow is the emitter. Ah, no, collector, rather. Am I right? NPN. Emitter, sorry. Yeah, that's correct. The first one is correct. So the one that has an arrow is the emitter. Okay. And then the other one is the collector. And then the middle one is always the base. Okay. So in NPN, it allows the electricity from the collector going to emitter. And then for the PNP, it allows the electricity or the electrons coming from this one uh, emitter, emitter, is it correct? Yeah, emitter, not amplifier, emitter, and then going to the collector. So it's the other way around. So in NPN, I think you guys are confused now. Sorry for that one. So NPN, uh, it is coming from collector going to emitter. For PNP, it is coming from emitter going to collector. Okay, so I hope that one is clear. So PNP transistor allow the electricity to pass from emitter pin to the collector pin. So they are represented in schematic with a line for a base, this one, and then a diagonal line connecting to the base, and then a diagonal arrow pointing towards the base. Okay. So again, for NPN, the electricity is coming from the collector, and then it will pass through the base, and then will come out to the emitter. And then for the PNP, it is coming from the emitter, and then it will pass through the base, and then to be outputted to the collector. Okay. So next one is integrated circuits. So integrated circuit is an entire specialized circuit. So what do you mean by entire specialized circuit? This or those circuits has been miniaturized and fit onto one small chip with each leg of the chip connecting to a point within the circuit. Okay, so as you can see right here, this is one example of IC or integrated circuit. It has 4 pins, 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, so these miniaturized circuits typically consist of components such as transistors, resistors, and diodes inside of it. Okay, you just can see it because it's inside of that covered plate of the IC. So for instance, the internal schematic for 555 timer chip has over 40 components in it. So imagine that one in a very small uh, circuit or PCB, it already has 40 components inside of it. Okay, so what if that is what do you call this technology? A nanotechnology or 7 nanometer technology or 12 meter 12 nanometer, yeah, 12 nanometer technology, 15 nanometer technology. I think right now the smallest technology is the 5 or 7 nanometer technology. So before we are in 7 nanometer, but right now we already have the 5 nanometer technology. Okay, so it can have millions or even billions of transistors inside of that IC. Okay? So the round notch on one edge of the IC chip indicates the top indicates 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 the top of the chip. Okay, so as you can see right here, it has a notch on the top. So that's an indicator that it is the top portion of the IC. And then the pin to the top left, okay, after, so let's say this is the notch, and then the left side, the top left, is considered the pin 1. Okay, so from pin 1, you read sequentially down to side until you reach the bottom. So from the top left, 1, 2, 3, 4. Okay, and then once at the bottom, say at the 4 or the last one, you move across to the opposite side, this one, of the chip, and then start reading the numbers up until you reach the top again. So from top, top left, going to the bottom, and then you will go to the opposite or the cross of it. Then that's already the continuation. Let's say 5, going to the top, up to the end. 5, 6, 7, 8. So that's how you see the connection of each pins. So 1, 2, 8. So keep in mind that some smaller chips have a small dot next to pin 1 instead of a notch at the top of the chip. So some doesn't have a notch, but it has an indicator where you see the top left dot, the black dot, that's already the first pin, okay, or the very first one. Okay, so any questions so far or clarification regarding with transistors, diodes, and then IC? Okay, sure. Don't have any this one. You don't have any curious question. Anyway, so if you can say so that you don't have a question then. All right, so let's move on to the next one. Next one is potentiometers. So potentiometers are variable resistors. So this one has resistors inside of it, wherein you can adjust it. So in plain English, they have some sort of knob. Okay, so this is the knob. You can turn it left or turn it to the right. So turn or push to change resistance in circuit. So if you have ever used a volume knob on a stereo or a sliding light dimmer, then you have already used a potentiometer. Is there anyone here who haven't used a potentiometer yet? Or maybe you have already used it, but you didn't know that it is a potentiometer. So in some old radios, we have this one, to control the volume or to control the signal. So we use potentiometer. So potentiometers are measured in ohms, since of course it's like resistors also. Okay, but rather than having color bands, they have their value rating written directly on them. Say 1M and so on and so forth. And then they also have this one. This is very important. They are also marked with A or a B, which indicated the type of response curve it has. So we have two types of potentiometers. So as you can see right here, it's very small, but this one has a letter B, as a letter of letter B. Okay, so potentiometers marked with B have a linear response curve. Okay, so what do you mean by linear response curve? This means that as you turn the knob, the resistance increase evenly. So it's even upon increasing or decreasing. So let's say if it's increasing by 10, then it can also decrease by 10. Okay, so 10, 20, 30, 40, 50. And then the potentiometers marked with an A have a logarithmic response curve. Okay, so this means that as you turn the knob from left right or right to left, the numbers increase logarithmically. Okay, the other one is increased evenly. For the letter A, it increased logarithmically. So what do we mean by that? So the first one is 10 raised to 0. The second one is 10 raised to 1. The third one is 10 raised to 2. The fourth one is 10 raised to 3. And so on and so forth. So as you can see, we have a value from 1 to 10 to 100 to 10,000. Okay. So if you see a markings of B, that increase an evenly or an even value, let's say by 10. But for letter A, it increased logarithmically. Okay, 1, 10, 100, 10,000, and so on and so forth. Right, so moving on. So a second. Alright, so sorry for that one. Our dog is noisy. So next one is LED. Okay, so I bet that all of you already know this one. So LED stands for light emitting diode. Okay, so it is basically a special type of diode. So LED or light emitting diode is a diode itself that lights up when electricity passes through it. So like all diodes, the LED is also polarized, of course, and electricity is only intended to pass through in one direction. So again, as I said a while ago, for LED, the longer one is the anode or the positive side, and then the shorter one is the cathode or the negative side. All right, where are we now? So there are typically two indicators to let you know what direction electricity will pass through the LED. So the first indicator that the LED will have is, like I said, the longer one is the anode and then the shorter one is the cathode. And then here's another way for you to know where is the positive or the negative one. So the other indicator is a flat spot, okay, on the side of the LED to indicate the positive. LED to indicate the positive cathode lead. I think this is there's a correction this one to indicate the negative, okay, negative lead, okay. So the flat spot here. So as you can see right here, the flat spot indicates the negative. So there's a correction in this one, negative cathode. Okay, and then the other one is already positive. So I have to change this one later. This one from positive to negative. So keep in mind that not all LEDs have this indication notch or that it is something wrong. So some has a notch or some has a flat spot, some doesn't have. Okay. So again, this one doesn't have a notch, but this one has. So like all diodes, LEDs create a voltage drop in the circuit, but typically do not add much resistance. So in order to prevent the circuit from shorting, you need to add a resistor in series. So it is always advisable that if you connect or if you have an LED, it must have a resistor beside it. So you may be tempted to wire LEDs in series, but keep in mind that each consecutive LED will result in a voltage drop until finally there is not enough power left to keep them lit. So if you have a series connection of LED, let's say you only have 5 volts and then you have 5 LEDs, of course, the first one will consume the 5 volts and then the remaining will consume the second one until the last one. So until become dimmer. So such, it is ideal to light up multiple LEDs by wiring them in parallel. So if you have a lot of LEDs, so yeah, it is always recommendable or it is advisable to have them in connection in parallel so that they have even electricity or even current. However, you need to make sure then that all of the LEDs have the same power rating before you do this. So different colors often are rated differently. So this blue one has a different or has uh, a required voltage of, let's say, 5 volts. The yellow one has a required voltage of 3 volts. The red one has a required voltage of 2 volts. So yeah, they have different power rating. Okay. so take note on that one. Next one are switches. So what is a switch or switches? So a switch is basically a mechanical device that creates a break in a circuit. When you activate the switch, it opens or closes a circuit, okay, or vice versa. This is dependent on the type of switch it is. So we have two types of two types of switches, rather. So we have the normally open and then the normally close. So from the word itself, normally open. So this switch just close the circuit when activated. Okay. So by default, it is open. And then if you activate it, it will close the circuit. And then for normally close, it is the other way around. It is already closed initially or by default. And then if you activate it, then it will open the circuit. Okay. So as switch get more complex, they can both open one connection and close another when activated. So this is a simple uh, way of doing it. But there are other switches wherein if you uh, close this one, it will open another circuit or another passage. So we call that one, or that type of switch is single pole double throw switch, or SPDT. Okay. So as I close the other path, it will open another path, or vice versa. As I open another path, it will close the other path. So if you were to combine two SPDT switches into one single switch, it would be called double pole. So for single, we call it one single pole. But for the other one, we call it one double pole or double throw switch DP-DP. Okay, so this would break two separate circuits and open two other circuits, or vice versa. Okay, so every time the switch was activated. Okay, so next one is batteries. So a battery is a container which converts chemical energy into electricity. Okay, so to oversimplify the matter, you can say that it stores power. There's a power in a battery. Okay, but of course those thing inside a battery are chemicals wherein can be converted into electricity. So by placing batteries in series, you are adding voltage of each consecutive battery. So you have to take note that one. If a battery is connected in series, you're adding the value to each other. Say 1.5, 1.5, 1.5, then you will have a value or a voltage of 4.5 volts. Okay. And then by placing batteries in parallel, the voltage remains the same. So still the same voltage output, but the amount of current available doubles. Okay. So if you have two batteries, it doubles the current. If you have three batteries in parallel, it triples the current. So this is done much less frequently than placing batteries in series, and is usually only necessary when the circuit requires more current than a single series of batteries can offer. Okay, so there are other circuits wherein it requires more current, so you have to put the batteries in parallel. But if it doesn't needed to have more current, then you can just put the battery in a series form. Okay, next one is breadboards. So breadboards are special boards for prototyping electronics. Okay, so this is where ECE or uh, people or ECE, good one, circuit enthusiasts do the work. Okay, so they are covered with a grid of holes which are split into electrically continuous rows. Okay, so as you can see right here, we have pass rows and then two columns of connected rows. Okay, so the left side, the most left side, and then the most right side are the bus rows, and then the middle one are the what do you call this one? Connected rows, horizontal connected rows. So in the central part, there are two columns of rows that are side by side. You see right here, they are side by side with each other, side by side. So this is designed to allow you to be able to insert an integrated circuit into the center. So this is where we put our ICs on the middle one. So if you do that, you now have a continuous connection between those two horizontal lines. Okay. So after it is inserted, each pin of the integrated circuit will have a row of electrically continuous holes connected to it. So in this way, you can quickly build a circuit without having to do any soldering or twisting wires together. So simply connect the parts that are wired together into one of the electrically continuous rows, and then on each edge of the breadboard, there typically runs two continuous bus lines. Okay, the bus lines. So the other one, the other side, let's say the left side, is intended for power, and then the other one is intended for ground. So by plugging power and ground respectively into each of these, you can easily access them from anywhere on the breadboard. Okay. So next, of course, you need wire to connect those components in a breadboard. So of course, you'll be needing a wire. So in order to connect things together using a breadboard, you either need to use a component. So you can use, a component. But mostly, of course, we use wire because we don't, let's say if we don't need that component, that of course, probably we'll be needing a wire to set up that component. So wires are nice because they allow to connect things without adding virtually no resistance to the circuit. It says here no resistance, but it has a very minimal resistance. Okay, as it passes through the wire, it already consumes or already has a voltage drop in it. So this allows you to be flexible as to where you place parts because you can connect them together later with wire. So it also allows you to connect a part to multiple other parts, of course. So the most recommendable uh, wire for the, let's say in prototyping or in putting that in a breadboard is a 22 gauge solid core wire for breadboards. So if it's smaller than that, then might overheat and then it might cause some fire. If it's too big, let's say 30 gauge, 50 gauge, then it is too large, then it will consume a lot of electricity. Like it already has a lot of resistance in it. Okay, so the smaller the connection or the thinner the connection, the faster the electricity will pass through. The thicker the connection, the thicker the wire, okay, the slower it will pass through, and then of course it will consume a voltage drop in it. So of course, as we all know, red wire is typically indicates a power, and then a black wire indicates the ground connection. But yeah, you can use this black one for the positive connection or for the power, and then vice versa. You can also use the red one for the ground connection. It's just that if you're let's say if you're electrical engineering, of course, if you do that, then you're only confusing yourself because we are teach or we've learned in school that the red one is for power and then the black one is for ground. Okay. All right. So next one is semiconductors. So do you guys have a question so far regarding with the basic components?
None, sir.
And all right. Right. So moving on, let's now talk about semiconductors. All right. So first, we have to know what is the meaning of semiconductors. What is a semiconductor? So semiconductors are used extensively in electronic circuits. So as its name implies, a semiconductor is a material that conducts current, but only partly. From the word semi, and then it conducts. So it conducts, but partly only. So most semiconductors are crystals. Okay. So take note, if it's semiconductor, should be imagining a crystal already, because most of them are in the form of crystals made of certain materials, mostly or most commonly are silicon. Okay, so this is the most common semiconductor. The second one is germanium. So silicon is used extensively as a semiconductor in solid state devices. Like for example, the one that we're using in computer, an SSD drive. Okay, so before until now, we're still using HDD or hard disk drive. The moving, it has a disk inside where it's moving. But for solid state device, so from the word itself, solid state, it doesn't have a moving particles inside of it. Okay, and microelectronics devices. So other usage of silicons are for dynamo and then transformer plates. Okay, so take note, silicon and then silicones are two different things. Silicon is the element, okay, single element. If it's silicones, it is already uh, another thing which combine with other elements. So those silicons are silicone oil, the one that is being used in cosmetics, the one that is being used in, say, for hair conditioners, for sealant, tire sealant, say, and others. Okay, there's a lot more that we can use for silicones. So this one is silicon, this one is silicones. Okay, so should take note on that one. So other examples of semiconductors, of course, other than silicon, we have germanium. Second most uh, familiar when it comes to semiconductor. We also have gallium arsenide and elements near the so-called metalloid. So as you can see right here, the encircled color red are semiconductors. We call those metalloid staircase because it's like forming a stair. So you can see. So we have a boron, silicon, germanium, arsenic, stibbium or antimony, tellurium, and what's this polonium, and then what is this one? I forgot the AD. Anyway, those are some, or those are the other types or other kinds of semiconductors. Okay, so after silicon, of course, the most common one is silicon. Gallium arsenide is the second most common semiconductor and is used in laser diodes, solar cells, microwave frequency integrated circuits, and many more. Okay, so all you need to uh, worry about is the silicon and then the germanium, because those uh, two semiconductors is the one that we're going to use for the entire midterms. The other one will not be used. All right. So for now, we will stop right here and then we will just continue this one again since we now only have 30 seconds. So goodbye for now. Later on for the part 3, I will discuss how are those elements made. All right. So bye bye for now. Again, have a break for 5 to 7 minutes.